For nearly 2 decades, Microsoft quietly invested billions of dollars into one of the most ambitious scientific gambles in modern history. Across secure research labs, from the Netherlands to Sydney, some of the world's brightest physicists were chasing a mystery, a particle so strange many believed it might not even exist. And yet, if it did, it could power machines capable of breaking encryption, curing diseases, and simulating the birth of stars. Inside Microsoft, this was called a moonshot. But engineers had another name for it: the ghost. To understand what happened, you first need to understand what they were trying to build. Classical computers, like the one in your phone or laptop, run on bits, zeros, and ones. Every image, every video, every calculation comes down to those two states. But there's a limit. Some problems are so complex, so layered with variables, that even the fastest supercomputers would take longer than the age of the universe to solve them. Drug discovery, climate modeling, protein folding. These are problems classical computers were never designed to handle. Quantum computers work differently. Instead of bits, they use qubits. A qubit can be 0, 1, or both at the same time. This is called superposition. And when qubits become entangled, their power doesn't just increase. It grows exponentially. 10 qubits can represent thousands of states. 50 qubits begin to rival supercomputers. And hundreds could surpass anything humanity has ever built. Companies like Google and IBM chose a practical path. They built quantum machines using superconducting circuits. They were fragile, error-prone, and extremely cold. But they worked. Microsoft looked at all of this and made a different decision. They bet everything on a particle that had never been proven to exist: the Majorana fermion. First proposed in 1937 by Ettore Majorana. A particle that is its own antiparticle. If real, it could enable something revolutionary: topological qubits. In 2018, a breakthrough was announced. A paper claimed evidence of Majorana particles. The scientific world reacted instantly. Headlines exploded. Funding surged. But behind the scenes, something didn't add up. Other labs tried to replicate the results and failed. Questions emerged: data inconsistencies, alternative explanations. And then, in 2021, the paper was retracted. What happened next was almost invisible. Labs were scaled down, teams reassigned, equipment packed away. No major announcement. Just silence. A global research effort slowly faded. This wasn't just a failure. It exposed something deeper. Quantum computing is one of the most high-pressure fields in science. Governments are investing billions because whoever succeeds first could break modern encryption. The stakes are enormous. And under that pressure, the line between discovery and interpretation can blur. In 2025, Microsoft returned with a new claim: a chip called Majorana 1. Early results look promising, but the scientific community remains cautious. Because in physics, belief is not evidence. The story of Microsoft's quantum lab is not just about failure. It's about the frontier of knowledge. A place where progress is uncertain and mistakes are inevitable. Somewhere right now, a physicist is staring at a faint signal. It could be noise or something extraordinary. We don't know yet. And that's exactly why we keep searching. Make sure to follow for more. Let me know in the comments, hit like, subscribe, and I'll see you in the next one.